We're going to focus just on the basics of start here. And let's talk a little bit about some of the other programming paradigms that you'll need to know. So we now have properties, we now have methods. Let's talk about variables. So a variable is any container inside of a method. So to get started, we're going to do something like var name equals Jesse Freeman, right? So here we have a variable, and you'll notice that I'm not defining this as string. And that's because C# has something called type inference. And type inference is really important because it allows you to not have to worry about the type. The compiler will automatically know that, hey, this is wrapped in quotes, it must be a string. And you'll see if I roll over this variable name, it'll give me the type string. I can also just do string, which is good as well. I tend to use type inference as much as possible. The only time I don't use type inference is when I need to create a variable container, and I don't know what it's going to be. If I did something like this and set it to null, you'll see that there's an error. I'll need to give it a type. So if I did string here, it'll automatically resolve itself. So later on, if I needed to use container within this method, I can actually I can access it, and it knows what type it needs to be. In this case, when we're defining something and we're giving it the value ahead of time, I just use var. Likewise, I said there were other variables you can use. Int is for numbers, so my age is 35. And you'll notice here, if I was to do something like 35.1, you'll see it'll throw an error. And it's telling you that this is a double, and it can't type this to an int. So here, I could do a double as age 2, or let's just do, I don't know, we'll do foo equals 35.6, and then I can use a float, which is a more precise floating point number, and I could do bar equals 30, let's just do 35.6. We could do the same thing here, but you'll notice that there's one specific thing. Right now it's typed to a double. That Unity doesn't, or the compiler doesn't understand that this needs to be a float, and in order to do that, we denote it with an F at the end. And the thing to note is that throughout Unity, we're going to be using floats a lot because all the world space is calculated in floats. So it's important to make sure that you have an F at the end of it. Also, again, because of type inference, I could just do var, and you'll see this will automatically become a double, and this will automatically, this should automatically become a floating point. So let's delete these. And the other thing that I wanted to do is talk about booleans. So a boolean is a true/false statement. So alive. I appear to be alive right now, so I'm going to set this to true. And booleans are important. They're used all over the place, and it's what helps us later on when we talk about sort of conditions. Let's see. The other thing we want to do, let's add another float here. And we'll do this as float speed equals 4f. So there may be a time where we need to calculate speed in our game, but sometimes there's some strange things that'll happen when you try to multiply a float by an int. And in this case, we'll do this float example equals. Let's just try to take the age multiplied by the speed and see what happens. So off the bat, this is going to resolve itself, and it's actually going to be okay. One thing that we could do, though, is that it may be better at times to actually take, instead of having an int and a float, we might want to convert them to the same type. So we could do something called casting. So here, we'll set this to float. And what happens is that this is redundant. We don't really need this, but I'm just showing an example. What's happening is that because I put this parentheses float in front of age, age is going to act as if it's a float now when we multiply by speed. Also, we could do stuff like, we could turn, let's say speed was like 4.5 or something. We could cast this to an int, and it would drop the remainder, and it would just become 4. So whenever you need whole numbers, you can cast floats to ints and vice versa.